Welcome to another in our series of videos where we're talking about number bases. In this video, what we're going to be doing is some random examples, totally random examples. Alright, extemporaneous examples. Extemporaneous. We have to pronounce the people word properly. Alright, some extemporaneous examples of making the switch from base 10 into other bases, because that is where you really start to understand that you understand what number bases are about. If you could switch from base 10 to another base, then you're on your way when number bases are concerned. And then you'll see that switching from another number base to base 10 is even simpler than switching from base 10 to another number base. But even making a switch from base 10 to another number base is simple once you understand that at the core, at the heart, everything dealing with the expression of numbers is what we refer to as a sum of powers. So in base 10, we're talking about the sum of powers of 10. In base 5, we're talking about the sum of powers of 5. In base 3, we're talking about the sum of powers of 3, etc., etc., etc. Alright, now in the last video we would have mentioned that we're leaving decimals out of the picture because that is a whole different level of calculation and analysis. If I have to transform, let us say 0.365 from base 10 to base 5, we leave that out of the picture for now. Alright, so we're dealing with whole numbers, we're dealing with numbers greater than 0. Yes, whole numbers, right? We're not dealing with any kind of decimals at all. Alright, so random numbers. If I want to express the number 75 in base, let me start. Yeah, so what I'm going to do is express the same number in different bases just to make the point. So we take the number 75. Let me start with base 5. 75, we know in base 10 is the sum of powers of 10. So in base 10, this is what 75 is. In base 10, you have 10 to the power of 0, 10 to the power of 1. Right, we wouldn't go past 10 to the power of 1 because it's 10. So 10 to the power of 0 is your units. So we have 5 units. 10 to the power of 1 is a 10. So we have 7 tens. Alright, that is what 75 is, which is the same thing as 7 by 10 to the power of 1 plus 7, not 7, sorry, plus 5 by 10 to the power of 0. That is what 75 is, equal 70 plus 5, which is equal to 75. Now, if we move in from base 10 to base 5, it means that instead of expressing this quantity, the quantity doesn't change. The quantity doesn't change. The only thing that changes is how we express the quantity. So instead of expressing 75 as the sum of powers of 10, we're now looking to express it as the sum of powers of 5. So we change the color of the ink and we say that instead of powers of 10, we have 5 to the power of 0, 5 to the power of 1, 5 to the power of 2. We wouldn't go past 5 to the power of 2 because 5 to the power of 3 is 125, which is greater than the 75 we're looking for. So our 75, look at here, 75. So this here is base 10 and this here is base 5, right? This here is base 10 and this here is base 5. Now, this is another trick here that I needed to pay close attention to and to remember. In base 10, because we're so familiar with it, we usually start from the small powers and we go up. So we say that we usually say units, tens, hundreds, thousands going up the road. Alright? Let's make this 0 a little smaller, just to underscore that it is a power and not part of the regular number. But you notice that when I write it out, I start with the highest power and I go down, which is a general convention that we use, which is something that advanced students would recognize. But here is not the place to talk about that. The convention is to start with the highest power of 10 going down the road. So we have 10 to the power of 1 and 10 to the power of 0. So following that convention, when we change in from base 10 to another base, in this case base 5, we start our analysis, we start our calculation from the highest power and we come down. So in this case, because the number is 75 and 75 is less than 125, 125 of course being 5 to the power of 3, 5 by 5 by 5, 5 to the power of 3 wouldn't form part of this analysis at all. Yeah? So we start with 5 squared. We know that 5 squared is 25. So 75 divided by 3 is 25. So in other words, 75 is 3 by 25. Alright? So immediately we could put 3 here. Alright? We could put 3 here, and we could put 0 here and put 0 here. So 75 in base 5 is the same thing as 3 by 5 to the power of 2. Right? And just for the sake of argument, I could say plus 0 by 5 to the power of 1, right? Plus 0 by 5 to the power of 0. So in other words, the same coefficient that we were talking about here, in this case the coefficient is 0, in this case the coefficient is 0, in this case the coefficient is 3. Whereas in base 10 across here, the coefficient of 10 to the power of 0 is 5, and the coefficient of 10 to the power of 1 is 7. So over here, the coefficient of 5 to the power of 0 is 0, the coefficient of 5 to the power of 1 is 0, and the coefficient of 5 to the power of 2, or 5 squared, is 3, which would then leave us with 3 by 25, which will give us back the same 75. So 75 in base 5 is 300. Alright? So let me just put it. So this is, we could change the ink here now. Alright? 75 base 10. In base 5 it is 300 in base 5. Alright? 300 in base 5, sorry. I shouldn't even say 300, because as soon as I say 100, that's base 10 immediately. So if we're talking about base 5, I cannot come here and say 300. I need to say 300 in base 5, 75 in base 10, and we're continuing. So we're going to go now and switch from base 5 to base, let me say base 4. We're going down the road, 5, 4, 3, 2, 1. Alright? So now let us do the same thing for base 4 that we did for base 5. Alright? So we change this to 5 here now. So instead of base 5, we're now dealing with base 4. And of course, because we're talking about the sum of powers, we start again whole numbers, so we can start from 4 to the 0. 4 to the power of 0, 4 to the power of 1 is 4, 4 to the power of 2 is 16, 4 to the power of 3 is 64. So we wouldn't go past 4 to the power of 3, because 4 to the power of 4 is 256, which is greater than 75. So that wouldn't enter the picture at all. So in other words, in base 4, 75 will be expressed as the sum of powers of 4, and those powers will range from 0 all the way up to 3. Right? Now the powers can be greater than 4. If the number is large enough, we can have 4 to the 5 and 4 to the power of 6. But the digits themselves, the digits that would represent a number in base 4, can only take values from 0 to 4. So we start from the highest power going down. 4 to the power of 3 is 64. 64 into 75 is 1, remainder 11. Right? So we could put 1 here because we have 164 and we have 11 now that we need to account for. Right? So that 11 will be divided between these 3 here. 4 squared is 16, which is greater than 11. So we can't deal with this at all. So we put a 0 here. 4, now this is not 4 multiplied by 12. In fact, I did a separate video on the difference between multiplication and exponentiation. Common mistakes that people make. You can always double back and check that. Right? Excuse. 4 to the power of 1 is 4. And 4 to the power of 0 is 1. So we have 11. Alright? We have 11 remaining. How are we going to divide that 11? 11 divided by 4 is 2. Remainder 3. Alright? 2 remainder 3. 4 2s are 8. 8 and 3 is 11. Now I doing this mentally. Right? If you need to write it out, write it out. If you need to consult a calculator, consult a calculator. But just make sure and get the process. So as you listen to me, it is always best to have a pen and a paper handy so you can make your little notes as you go along. So 11, which is the remainder when we divide 75 by 64. 11 divided by 4 is 2 remainder 3. So we can put the 2 here. Alright? And then the remaining 3, remember 4 to the 0 is 1, which is 3 by 1. We could just put the 3 as the remainder here. And that is 75 in base 4. Now, if we need to write it out, this will be the same thing as, watch it now, 1 by 4 to the power of 3 plus 0 by 4 to the power of 2 plus 2 by 4 to the power of 1 plus 3 by 4 to the power of 0, which is the same thing as 1 by 64. This 0 does be 0 plus 2 by 4 plus 3 by 1, which will be 1 by 64 is 64 plus 2 by 4 is 8. 64 and 8 is 72 plus 3 is 75, and that will give you back the same 75 that you started with. So 75 in base 4 is, I'm coming back here now, 1 0 2 3 in base 4. So we go from base 4 now to base 3, 2 and then base 1. Alright, so that's base 5 and base 4. We could just go in base 3 and base 2. So we could save base 3 and base 2 for the next video. Alright, all you have to see, we starting the rubber for the next video already. Alright, let me see if I could squeeze in base 3 here first now. Alright, I had to make these quick decisions when I'm making these videos. So base 3. So 75 in base 3. Remember, we're talking about powers of 3. So we're looking now at base 3 would be wrong color of ink. That would be 3 to the power 0, 3 to the power 1, 3 to the power 2, 3 to the power 3. Alright, we wouldn't go past 3 to the power of 3 because 3 to the power of 4 is 81, which is greater than 75. Alright, so Base 3. Again, we starting from the highest power. So 75 divided by 27 is how much? 27 by 2 is 54. 54 and the 21 is 75. Right? So 75 divided by 27, 3 cubed is 27, right? In case you were wondering where I get the 27 from. 75 divided by 27 is 2. So we put the 2 here. 2 by 27 is 54. 54 and the 21 is 75. So we have 21 to share between these guys here. 3 squared is 9. So 21 divided by 9 is 2 remainder 3. 9 2s are 18. So 2 remainder 3. 3 to the power of 1 is 3. So 3 divided by 3 is 1. 1. And then the remainder 0. 0 to the power of 1. So that in base 3, 75 is 2210, which is the same thing as, watch it here, 2 by 3 to the power of 3 plus 2 by 3 to the power of 2 plus 1 by 3 to the power of 1 plus 0 by 3 to the power of 0, which is 2 by 27 plus 2 by 9, bracket here, bracket there, plus 1 by 3, which is the same thing as 2 by 27 is 54, plus 2 by 9 is 18, plus 1 by 3 is 3. 54 and 18 is 72, 72 and 3 is, guess how much? 75. Alright, so in base 3, our 75 is 2210, base 3. And the next one we're going to do is base 2. Alright, that's one of the more common bases that we use when we're making the shift from base 10 to other bases. So we're continuing in our series here where we're taking this one number 75 and we're expressing 75 in different bases. So we have 75 in base 10, which is 75 as we know it. 75 in base 5 is 300. 75 in base 4 is 1023. 75 in base 3 is 2210. How about base 2? Remember, the essential premise, the foundation, the core is that the number base system. Basically we're talking about representing any number as the sum of powers. So if we're talking about base 2, we're basically representing 75, the quantity 75. Remember, there's a difference between a quantity and a number. 75 is 75 in any base. What would change depending on the base that you use is the manner in which the 75 appears. So in base 10 it would appear as 7 with a 5. In base 5 it would appear as 3 with 2 zeros. This is what it will look like in base 4, and this is what it will look like in base 3. Yes, I know, I just repeated something that I would have said 5 minutes ago, but that is the whole point. Sometimes you have to do that to drive the point home. So in base 2, we go in again. Powers of 2. Alright? Now we see, we're doing base 2 this time, right? So the base this time is base 2, which means that we're operating in powers of 2. So we start again. 2 to the power 0, 2 to the power 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. Now we need a little more space here. So we will go down. We'll go down a little bit. Alright? So 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 3 is 8. Sorry, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, and we wouldn't go past 2 to the power of 6 because 2 to the power of 7 is 64 by 2, which is 128, which is greater than 75. So in other words, the number 75 we will express as the sum of powers of 2, and because of the exact quantity that we're dealing with, we know that we wouldn't go past the 6th power of 2. So, as we did before, we start from the highest power and we come down. 2 to the power of 6 is 64. So, 75 divided by 64 is 11. Sorry. 75 divided by 64 is 1 remainder 11. See, I just skipped a whole set of information there and I went straight to the 11. So 75 divided by 64 is 1, so we put a 1 there. So we have 11 to be divided equally among all these remaining powers. Not equally, just divided. 2 to the power of 5 is 32. That's out of the question because that's greater than 11. 2 to the power of 4 is 16. That too is out of the question because that is greater than 11. 2 to the power of 3 is 8. So we have something here now. So 11 divided by 8 is, guess how much? 1. With 3 as the remainder. 2 to the power of 4 is 2. 2 to the power of 2, sorry, is 4. Yes, that is what happens sometimes when you're going and you're making videos and you start to get to the point of fatigue. You start to make silly mistakes like that. Alright? 2 to the power of 2 is 4, but we have 3 remainder. So this will be out of the question. We're dealing with 3 now. We're trying to divide 3. 2 to the power of 1 is 2. Aha! 3 divided by 2 is 1. 2 into 3 is 1. Remainder 1. And then 2 to the power of 0 is, guess how much? 1. And we put the 1 right there. So 75 in base 2 is equal to 1 by 2 to the power of 6 plus, I'll put in the zeros just for emphasis, but we don't have to put them. Maybe you would have realized that by now. Plus 0 by 2 to the power of 5 plus 0 by 2 to the power of 4 plus 1 by 2 to the power of 3 plus 1 by 2 to the power of 2 plus, sorry, 0 by 2 to the power of 2 plus 1 by 2 to the power of 1 plus 1 by 2 to the power of 0, which is equal to 1 by 2 to the power of 6 is 64. No, let me just, which is 1 by 64 plus, I'll leave it on the zeros now in the interest of space, right? 0 is 0, we don't need to put that. 1 by 2 to the power of 3 is 1 by 8 plus 0, we're leaving that out, plus 1 by 2 plus 1 by 1. 1 by 64 is still 64. 1 by 8 is still 8. 1 by 2 is still 2, and 1 by 1 is 1. 64 and 8 is 72. 72 and 2 is 74. 74 and 1 is, guess how much? 75. So 75 in base 2, excuse, would be, how have it? 1 0 0 1 0 1 1 in base 2. Alright, so we have used the explanation that we gave for a number base to express one number, 75, in several different bases. We express it as base 10, which is what we're familiar with, which is what we are accustomed doing. This is what we use when we count, generally speaking. That's the normal base. Right? The common base is that's what we use. 75 in base 5 is 300. 75 in base 4 is 1023. 75 in base 3 is 2210. 75 in base 2 is 100101112. That basically is it as far as 75 being expressed in different bases from base 5 straight down to base 2. Couldn't want it better than that. Alright, so we have the foundation here, having seen that number bases are essentially a sum of different powers. We now are in a position where we could change from base 10 to any base that we care to use. So there you have it. There you have it. We have come to the end of the first part of me explaining number bases. We started by going at length in talking about what base 10 entails, and then using that as the foundation to switch from base 10 to other bases. And we used the example of the number 75, where we express 75 in base 10, and we change the base to 5, to 4, to 3, and to 2. Fair enough. Alright? So, as always, I want to encourage you to keep working hard. Remember, seeing the explanation in the video is one thing, but the way in which you would cement your understanding is to do questions, and you want to do plenty questions. You want to do so many questions that there is no issue of second guessing yourself. Alright, especially when you're under the pressure of an exam. Alright, dabbling around in questions when you have whole weekend to do it is one thing. Doing it under the pressurized environment of an exam is a different matter altogether. So you want to be able to express yourself correctly under pressure. That is what we're preparing for. And when you could express yourself correctly under pressure, that is when you know that you know it. That is when you know that you could do it. That is where you start being in a position where you could apply it to almost anything that you're doing that requires it, and where you could explain it to somebody else if you have to. So, I hope you enjoyed this series of videos. I hope you enjoy the videos in general. And just stay in tune and look out. We have plenty more coming your way.